students, welcome to the next video of measures of dispersion. In today's video we are going to see the types of measures of dispersion, mainly absolute measures and relative measures. So let's start. Now absolute measure is the measure the dispersion in the original unit of the data. Okay, absolute measure measures the original unit of the data. Okay, without original unit we can't apply the absolute measures of dispersion. Then variability in two or more distribution can be compared provided they are given in the same unit and have the same average. Okay, if uh, two or more distribution having the same unit, same average, then only their variability will be compared by using the absolute measures of dispersion. And practically this is not possible. If there are two sets of data, then definitely they will not have the same average or same units. So the here comes the next measures of dispersion, and that is known as a relative measure of dispersion. So it measures the dispersion, and in this dispersion is free from unit of measurement of data. Okay, so to overcome the absolute measure, to overcome the difficulty of absolute measure of dispersion, we are discover the relative measure of dispersion. So it is a free from unit of measurement of data. It is the ratio of the measure of absolute dispersion, and so it is not depend on the average. Okay, it is free from the average. So uh, when it is when we are interested in comparing the two sets of data, then it is better to apply the relative measures of dispersion. Why? Because relative measures of dispersion is free from the unit of measurement. Okay, it don't require the same averages. From the different averages we can calculate this relative measures of dispersion. Then it is the ratio of a measure of absolute dispersion to the average from which absolute deviations are measured. Okay, relative measurement is based on the absolute measure. Okay, from the absolute measure we are finding the ratio, and it is called as coefficient of dispersion. Okay, so that's why relative measure of dispersion is known as the coefficient of dispersion. So basically we are having two types of dispersion. One is absolute and the other one is relative measures. So class students, there are four absolute measures, and we are having, whenever we are interested in comparing the data, then we are having, or we have to find the relative measures. Okay, so let's see the example. Before example, let's see more about this. So now once again see the difference between absolute and relative measure of dispersion. So as I told you, absolute measure has the variable unit. Okay, and in relative measure there is a no unit. Okay, absolute measure is depend on the unit. It is require the same unit and same averages for comparison, while in relative measures there is a no unit. Then in absolute measure it is not expressed in terms of percentage. Okay, this is a single value. Absolute measure is give you the exact value of the distribution. Okay, if there are more than one distribution, then you will get the value for each distribution, and that's why we are not able to compare the distribution. And relative measure express in terms of percentage, and that is why it is used to compare the distribution. When there is two or more different distribution, then we are using relative measure for comparison. Then third is a in absolute measure calculated from original data. From the original data we are going to calculate the absolute measure, but in relative measure calculated on the basis of absolute measure. We use the absolute measure and will calculate the relative measure. This relative measure is nothing but the ratio of absolute measure. Okay, so using this absolute measure we are calculating relative measure. We will convert this relative measure in percentage, right? And it is common for all the distribution, and that's why we get a some common part, percentage part for all the distribution, and that's why we can compare all the distribution. Now let us see the types of absolute measures. Okay, so there are four types of absolute measures of dispersion. In your syllabus you are going to learn absolute measure. In that first you are going to learn range. Okay, range is a absolute measure, and as I told you, from this absolute measure we are going to calculate the relative measure. So relative measure of range is coefficient of range, right? As I told you, relative measures are known as a coefficient, right? So range is a absolute measure, but we cannot use range for comparison, and hence we are going to find coefficient of range, which is a relative measure of dispersion. Then second measure of dispersion or absolute measure of dispersion is mean deviation. In your syllabus you are only finding the mean deviation, no relative measure for mean deviation, only absolute measure. Then next is variance. Okay, next measure of dispersion is variance, and on the basis of variance we are finding the next one is standard deviation. And absolute measure, standard deviation, variance and mean deviation, three of them are absolute measure of dispersion. And for standard deviation there is a relative measure which we are going to use for comparison, and that is known as a coefficient of variance. Okay, this coefficient of variance, this coefficient of variance is used as a relative measure for comparison. Okay, so in your syllabus you are going to learn range, then mean deviation, then variance and standard deviation. All these four are types of absolute measure of dispersion. Okay, then for range you are having relative measure of dispersion, which is known as a coefficient of range. For standard deviation you are having a relative measure of dispersion, which is known as a coefficient of variance or COV. Okay, now let us start with the first absolute measures of dispersion, and that is range. Now you are very clear about the range. We all know that what is a range. Range is what? The spread of data. In very simple way, range is a highest value minus lowest value, right? We can find the, suppose data is 7, 9, 1, 18, then 16, then 5, then 20, then 9, then 7. Okay, this is suppose data. So and I am interested in finding the range, spread of data. My data is which number to which number, right? I'm interested, my data is spread over which number to which number. Okay, so for that, very simple method is find the highest value and find the lowest value, then highest score minus lowest score, this will give you the spread of data, right? So from 20 to 1, my data is scattered, right? And my range is 19. Okay, so this is the simple definition of range. So range can be defined as difference between the lowest value and the highest value. Suppose this is the data, then find the lowest value and highest value. Lowest value is 3, highest value is 9. So range will be 9 minus 3, so that means 6. Okay. Now let us see the formula of range. So as I told you, range is a highest value minus lowest value. Okay. Then there is a relative measure for range, which is known as a coefficient of range. And coefficient of range is range upon h plus L. Okay. So coefficient of range is h minus L, that means range upon h plus L. Okay, so formula for range, it is h minus L, and coefficient of range h minus L upon h plus L. So with this I am concluding this video. Thank you, students.